All right, question 1.2. It's another sort of visual pattern that we are looking at. And this is a classic question where there's that saying that goes, there's many ways to skin a cat. And this is a type of question in maths where there's not one necessarily more right way of answering this question. And you can use a number of approaches. I'm just going to show you the one that I personally favor, but you can answer this question in different ways. So first thing I'm going to do is just look at the actual visual pattern, count the matches just so I can see for myself. The first pattern, there are 4 matches there. Second one, they're going to be the 4, and then the 3 additional. I'll just kind of show you what I mean. I'm looking at those 3 additional ones from the original pattern. So that's 4 plus 3 is going to give me, that pattern has 7. The next one's going to be the 7 plus another 3 additional ones there. So 7 plus 3 is 10. And then I can sort of identify that with the table below. That's all I'm looking at. The table below is just a way of numerically representing the visual pattern of matches. So we asked to complete the table. So hopefully you've picked up the pattern that each time you move on to the next pattern, you're just adding another 3 matches each time onto the edge of the pattern. So basically, as we move along, we're going in sort of multiples of 3. So we're adding 3 each time. And that makes it fairly easy to work out the next number in the pattern, because it's the matchstick pattern number 4. I just need to add another 3, so that means that that'll be 13. But then it immediately jumps to matchstick pattern number 20. So we've been going nicely along the top here, just 1, 2, 3, 4. We just need to add 3 matches each time. But then suddenly we jump to 20. Now that's a jump of 16 matchstick patterns. But luckily I know the general pattern is a multiple of 3. So all I actually need to do is take 16, multiply it by 3. Hopefully you can sort of do that, just maybe work it out on the side. I'm just going to do it on the side over here. 16 times 3. It's 18, carry the 1. So that's 48. So basically, to get from here to here, I'm actually adding 48 because I'm going up 16 patterns. So then I just need to add 48 to 13, and then 48 to 13 is going to be 61. Okay, and then here comes definitely one of the trickier questions you get in this section of maths, is where we're actually given now the number of matches, and we have to work out which matchstick pattern. So we're basically working in reverse. Now, the way I would do this, I would actually answer the next question first. I'd find the formula and then use that. But if you don't have the formula, what you do know is that our starting point is 4. So what I'm going to do, and I actually don't really have any space to show you this, let me just make a little bit of space up at the top here. Working backwards, I'm going to take the 121, and I know that the first pattern is 4, so I'm going to actually subtract 4 from 121, which will give me 117. And I know from there, 117 should be divisible by 3, because it's going in multiples of 3 each time from your starting point of 4. So I then take 117, I divide that by 3, and that will give me 3, carry the 2, 3 goes into 27, 9 times. So that's going to give me 39. If I had to times 117, 3 times 39 would give me 117. But I've got to remember that it's the first pattern is the 4, so I then need to add an additional number to the 39. So this will effectively be the 40th matchstick pattern. And then I'm going to take you to the formula, and we'll see that this actually does work. So basically, we want to find out, usually our goal is to find out the number of matches. So we say that is represented, and it's highlighted in bold here, N. So we say n is equal to, and there is some link between the number of matches and the matchstick pattern number. So there's a link between these two, what we call variables, because they vary. You see the matchstick pattern changes. It goes 1, 2, 3, 4. We can have any matchstick pattern we want. And based on that, we want to know how many matches there are. So those two things vary together. So there's a link between them. Now the most obvious link we've already identified is this multiple of 3. So mathematically, I know that there is some kind of link where it's a multiple of 3. But now, if I had to use substitution, and I just take the first example where there's matchstick pattern number 1, and there are 4 matches. If I substitute matchstick pattern, which is number 1, is t. So if I put a t is equal to 1, 1 times 3 is 3. However, it's telling me that it should be 4. So then mathematically what I have to do to adjust for that is I just have to add 1. Okay, and the beauty of a general rule is it works for every single case of the pattern. So let's just test it out randomly on maybe, let's say, the third one. So when we've got matchstick pattern 3, so t is 3, so we make t 3 over here. 3 times 3 is 9. 9 plus 1 is 10. So n is 10. And when t is 3, n is 10. So this is now a general rule that works for all of them. So we can actually go and test the ones that we've done. So for example, when t was 20, 20 times 3 is 60. 60 plus 1 is 61. And it works perfectly. On to the final one, just to double check that we're right. 40 times 3, 4 times 3 is 12, so it's 120. 120 plus 1 is 121. N is 121, and we've done it. Alright, we're now on to a bunch of questions that are equations. And equations, you will learn quite a few techniques to help you solve equations. But the main technique we're going to use in grade 7, and you should be able to basically use for any equation you get, is just inspection. And inspection is basically just means a sort of trial and error approach where you can substitute in a value for the variable to make the equation work. So the first one's really should be pretty straightforward. So you're basically saying, well, 2 times what will give me 10? And that will be a. So 2 times 5 is 10. We should know how to do that. And then we've got the first answer already. A must be 5. That's what makes the statement true. The equation is a statement. 2 times something equals 10. 2 times 5 equals 10. Okay, then it gets a little bit trickier as we go on, but we'll take it step by step. So we've got 5 minus 2b equals to 1. Now we can actually break this up into 2 parts. 5 minus what will give me 1? Hopefully you know 5 minus 4. So we want that whole thing to be 4. So basically we're saying, well, 2b is equal to 4. And then we're back to the same thinking as the first question. Well, 2 times what is equal to 4? 2 times 2. That must mean that b is equal to 2. And we can test it. 5 minus 2 times 2 is 4. 5 minus 4 is 1. So b must be equal to 2. Okay, then the next question, it's saying a quarter of something is equal to 5. So it's basically rewriting it. A quarter times something is equal to 5. So this one, for me, again, I can just sort of think, well, it's almost like reverse thinking. So I'm almost taking that 5 and I'm multiplying it by 4. A quarter of 20 is going to be 5. I mean, if you think about it, if you had to break up anything into quarters, I'm just drawing a diagram there. 5, 5, 5, and 5. That gives you a total of 20, but you're only interested in a quarter of that. So it's a quarter of what? Therefore, y in this question, y must be equal to 20. The next one, something divided by 2 equals 15. Almost as straightforward as the first question, really. So we're trying to think of something divided by 2, which will give us 15. Again, I use the reverse, thinking, well, 2 times 15 is 30. So the answer must be 30, because 30 divided by 2 is 15. So M is going to be 30. Okay, so yeah, with equations and with inspection, it's really important that any mathematical operation you can reverse. So when you're dividing, you need to be able to multiply. When you're adding, you need to subtract, just to kind of do the reverse to help you solve the problem. Okay, then the last one, we just also want to break this maybe up into parts. So we're thinking of 6 divided by c. 6 divided by c plus 4 equals 7. So before we even think about the 6 divided by, what plus 4 equals 7? 3. So I'm actually, what's in red there, the 6 over c must be equal to 3, because I need 3 plus 4 to give me 7. So now I need to think, well, what do I need to divide 6 by to get to 3? And hopefully that you can do by inspection. 6 divided by 2 will give me 3. Therefore, c must be equal to 2. And you can put that back into the original equation. 6 divided by 2 is 3. 3 plus 4 is 7. And we're done.